Hello everyone, this is Crossfire. Welcome to another tutorial on 83 and Playmaker. Today we will be looking at how to create a Flappy Bird prototype, and in the same way we will be looking at how to do a platformer in Unity using Playmaker, something like Mario. So that way we will be using Playmaker in making a awesome game. So let's get started. This is going to be our scene. I have nothing special loaded up. It's just the default main camera and directional light, except for the main camera has a orthographic projection and I set the size to 20, so that's the only difference. So I'll just quickly create a cube in the world space. Okay, maybe we will switch back to 10 or something. Yeah, so this is going to be good. So I'll just do a thing, yeah, so that we can see what the actual camera looks like. My scene view has some sort of weird happening, so I'll just re-add it. Yeah, now it's working fine. So we will be using this here, and I'll just scale it up like that. Okay, first we will be looking at Flappy Bird, then we will go back to the platformer, something like Mario. So this is basically a reply to a comment. Someone asked for a Flappy Bird, or say Mario in Playmaker. So this is going to show how easy it is to use Playmaker and making such games. So let's just get started. So this is going to be our bird, this tiny little thing. So we'll just duplicate this, and this is going to be our wall, the upper wall, the constraint. So just quickly grab that and give it a lower wall as well. So this is going to be our upper wall and lower wall. This is going to be our bird. So I'll just quickly add a component widget body, and we need the collision detection to be continuous as it's going to be moving, and it will be using gravity, and it will just be in the Z, sorry, this one, yeah, so that it doesn't go forward. The collisions will be disturbed if the Z position isn't locked. So we need the bird to be at 0, as well as the walls and any other obstacle in the game. So we'll just quickly add an FSM for the jumping of our bird. So as you can observe in the game Flappy Bird, you can see that the bird is at a fixed position, where when you touch the screen it would go up. There are two types of movement, where when you tap it's going to be jumping, and when you hold it will just be going up. So the longer you press, the longer it will jump. So that is the basic mechanic we will try to emulate. here. So in the first state, I'll just give it a name of input, and I'll just say key down since we are not building for Android right now. I'll just use a space bar, and I'll send an event called finished, and in state 1 it will be jumping. Sorry for that. And in the second state we will be adding set velocity, where we need the y of the player to be 0, because we need the jumping to happen from where it has like when we enable gravity, it's going to be concerning the gravity. So I'll just show you how exactly it would work without the set velocity function here. So I'll just be adding force on the y-axis, and I'll give that a force of 200 in the cell space, okay, world space, because we want it to go upwards, doesn't matter. So, and it'll just go back to the first state. I hope that should do. So you can see that when it's going down, it's not giving the Flappy Bird effect. And what exactly is the Flappy Bird effect is that it'll jump exactly from the position it was like assigned. So that is the basic effect that we are looking for. So I'll just tweak this value to 300 and just hit play so that we can see whether it's going to be good. And it's good, I guess. So now we will be creating the obstacles that we need for our game. So it's working fine. We'll just stop the game and go to the view. So now we will be just creating a cube, not a cube but a wall kind of thing. So I'll just duplicate this and bring it here. I'll just keep it here and look at the visual. So it's doing fine. So that will be our basic reference, so that the vertices are snapped exactly. You hold V to choose a vertex and then snap. Yeah. So this is going to be our obstacle, but that alone is not an obstacle. So I'll just duplicate this and bring it here. So we'll just take a look. 24.94, and we need to be specific about the values. So we'll just see whether these are, the player won't be able to fit in these, so we'll just reduce these sizes of these a little bit, and you can see that this will be doing fine, except we need to just, for reference sake, just play and test it. Yeah, so that is going to be fine, as the obstacle will be moving, and we will be using these obstacles to move in the negative x-axis. We will have the camera fixed and the background changing and stuff like that. So you can see that you can actually take a look at the scales. It's 2.2 and this is 6.5. Yeah, 6.5, and I'll just make this rounded off, 7.6 and 6.5. so you can see that these ratios are important for these obstacles, because we can either use templates or you can use randomized integers to set the scale of these basic obstacles. So I'll be using templates for this tutorial, and I'll make a tutorial on how to randomize the scale based on integers and floats if you make a request in the comment section. So this is going to be template based, so I'll just create a empty object, and I'll just bring it down right to the middle and drag it back, and I'll call this wall type 1. So I'll just do this, and this will be one game object, so that way we can use the wall type 1 to spawn at the place, and actually we can even use the same to kind of move up and down instead of changing the scale. Okay, so that way we need not worry about the randomization. So this is going to be 0, and I'll just do a thing. I'll set these long enough, and now what we can do is set the y axis for this to spawn. So this is 0, and this is going to be only one type of wall. So I'll just go into the project, and we have Flappy bed here. So in Flappy bed I'll just make a prefab. So there we go, we have a prefab there, and you can see that this is the normal value for y, and if I increase it to 2, or 5, let's just say 5 and -5, so that is going to be the principle on which we will be spanning these walls, except we will just take a reference game object and drop it into the scene, then delete the wall. So this is going to be our spawner, so I'll just name it spawner. And we forgot something very important, that is adding an FSM to the wall, and just call this move left, and in this state it will just translate in the negative x-axis. Let's just say -5, and let's just test it so that we will match the speed at which the wall is coming. Well, that is good, I guess. Okay, you can see that our bird has changes for rotation. Yeah, so maybe we should tweak the scale on the bird. Or the speed at which this is translating. So we need to translate at a higher speed. Let's set that to 8 and let's see whether that is going good for us. So that seems to do the job because that is cool, but the player is not still fitting into the wall space. So just put this to 12 or something. Maybe that will be a little bit faster. Ouch, that is a little too much faster. So -10 will do good. And maybe we should even change the... Okay, now it's completely good. It was exactly genuine. So I'll just save the scene and this will be our -10 would be our speed. So now that it's saved, and click apply so that it applies to the prefab, and just destroy it, delete it. So at the spawner we need to have an FSM where I'll just say randomize position. So in this FSM what we would do is set move randomly, because we need the walls to be spawned at different positions. So I'll just go to random int, and that is going to be minimum of -5 to +5, and it will store a result of, let's say, we will store this as y inclusive of the max, and it will set position of the owner. Now you can see that if I go to the y, you cannot see any variable that we stored. That's because we need to convert the integer to a float and then use it and set position by float every frame. And y float will be our new y position. So we need not actually have this every frame tagged, because we will be okay. That doesn't make any difference. So I'll just add a weight, and this is going to be randomized at every, let's say, 0.25 and finished, and this is going to be at real time. So I'll just save, and when I hit play we will observe the spawner, and you can see here at the position transform, you can see that it is completely changing the position of itself. Okay, so that is completely working, and we need another FSM on this, and this is going to be create walls. Now create walls will be create, I'll just create object. It is as simple as that. We will create a game object called wall, and this is going to be our game object, and the spawn point would be itself. Position and rotation, we need not do anything out at this, so I'll just wait, and I'll wait for, let's say, 1 second, and we will just try this at real time. So I'll just hit play, and for every 1 second it would spawn a wall with random height. So you can see that it is already working. We have a Flappy Bird prototype, but we need this to be a little bit, something like 2 seconds. And we have a kind of good Flappy Bird prototype. This is good, except for the player scale. We should really tweak it because he's touching the walls every time he goes inside. So that way we can create this beautiful Flappy Bird prototype. Just start, and I'll just go to bird, and maybe I'll just do a 1. Okay, 1 is too much. Let's say 1.5 and 1.5 on the Y. So maybe actually you can change the scale depending upon how your game should feel like, whether it should be very irritating like the traditional Flappy Bird, or it should be easier for the player to play. Ouch. Okay. That's good. Okay, now you can see that we have a lag in our game, and you can see many walls that are being spawned, and you can see the wall, it's right here, and this is, let's say, -30. Yeah, so that is -30. So what I meant to fix is that you can go to edit prefab and add another FSM where it says kill, and this time we will just get the position of the owner, and I'll store the X and X every frame, and int compare, and if, okay, what the hell, yeah, okay, not float compare, sorry, because our position is a float. Yeah, so float compare X, if it is less than -30, you would go to hell. So that is kill every frame, and kill goes to destroy self. So let's just save it and delete this and hit play. Now it should work fine because the collisions were not properly working for. We will go to kill and let's count. These are 5 walls. So okay, they're increasing, not decreasing. Get position. Okay. Float compare x to the self axis. Okay, even then it's not working. That's not fine. Let's just drop it in again. Let's just disable the spawner and we will test only one wall this time. And kill. Get position x in the world axis. And it would send a float compare. Tolerance is 0. And if x is equal or less than -30, it would send anywhere to kill it. So now it should do fine, counting, and it's on. It's working. So that's what exactly we need. So I'll just hit apply and I'll just delete this wall and enable the spawner and we'll just play Flappy Bird. So you can see that now it's completely working. Oh, that's a nice tweak. Ouch, that was close. Wow, I haven't played Flappy Bird like this good. So now we can just drop in another FSM where we will just detect collisions, and here we would say collision event, and if it's a wall then I will just reset the scene and reset the scene. We can go to level. Yeah, so I'll just hit play, and if I hit a wall this time I will just start at the same place. Ouch, that's now it seems hard. You can see that this is seriously not going beyond. Okay, I just went past. Okay, 2 is my highest score, I accept. So this is the basic setup for something like Flappy Bird. So I'll just make a quick tutorial on Mario, how to create such game later. I'll be continuing this series, and so we can have like animated sprites coming in instead of this faceless textures. So see you in my next video. This is Crossfire signing out. Have a good day.